Okay, one last little piece before we get into example one. Here it says in the book, unit circles commonly used to show the exact values of cosine of theta and sine of theta for special angles. The cosine values are the x-coordinates of the points where the terminal sides of the angles intersect the unit circle, and the sine values are the y-coordinates. So this is a very busy image. This is an image that I would never, ever, ever in my life ask you to memorize, but it is one that I'm going to expect that you could fill out on your own without having to memorize any part of it. Let me kind of review what you're seeing in this picture. So we're seeing angles around the center that are in degrees, 0, 30, 45, 60, 90, up to 180, all the way around to 360. And then we're seeing radians above those. So 0 is still 0 radians. 180 degree is pi radians. 360 degree would be 2 pi radians. So we've got all these same points just listed as radians. And then we've got the coordinates along the edge of the unit circle. The coordinates, which the x value is your cosine of the angle. So if I say, what's the cosine of 30? The answer is square root of 3 over 2. And if I say, what is the cosine of pi over 6 radians? The answer is still square root of 3 over 2. If I ask for the sine of 30 degrees, then it's 1/2. If I ask for the sine of pi over 6 radians, it's also 1/2. Okay, so that's the information that's around the circle. Now, there's no reason to memorize these, and they'd be terribly difficult to memorize because they are so similar to each other, right? Now, all you need to memorize is that those values come from two types of triangles. An equilateral triangle that was cut in half. That's how we get 30, 60 degrees in a right triangle. And a 45-degree right triangle. So all of these have to do with making right triangles that include these angles. Now, the only ones that you really need to know is 30, 45, and 60. Everything else is just built off of those. So, like if I go back to that unit circle, if we ask for the sine of pi over 6, it's 0.5. Well, the sine of 5 pi over 6 is 0.5. And the sine of 7 pi over 6 is the only difference. It's a negative 0.5, but it's just that length of the green line. So there's like 4 locations here that have the same length as pi over 6, as 30 degrees. Well, there's also 1, 2, 3, 4 locations that have the same length as pi over 4, or 45 degrees. There are 4 locations, 1, 2, 3, and 4, that will all match with 60 degrees, which is pi over 3 radians. So as long as you just know these 3, you technically can just sort of jump over and know what these 3 are, what these 3 are, what these 3 are. And the quadrantal ones, the ones that are dividing the quadrants right on the axes, those we can kind of simply figure out in other ways. Okay, so like I said, those come from these triangles. So I always start by doing an equilateral triangle with 2 on each side so that I'm not doing fractions. But in reality, what we're really looking for in the end is one with a 1 here. So you'll have 1/2, because that's half the length of that hypotenuse. Right? It was the equilateral triangle on the bottom where the whole thing was 1, so this must be 1/2. Then you can solve out what this one needs to be using Pythagorean theorem. Same story over here. We do 1, 1, and this has to be square root of 2. Then we can kind of move to this triangle. So I sort of suggest starting with these ones because these ones are the ones where it's much easier to look at and know that these numbers satisfy Pythagorean theorem. So we know that when we square the two shorter sides and add them up, they should be the same as the square of the hypotenuse. Well, here 1 and 3 makes 4, 1 and 1 makes 2, saying the numbers when you square them. Here, those numbers get a little bit harder to do just in your head. So I kind of suggest that you start here and then you scale it such that your hypotenuse is 1. So for this one, everything needs to get divided by 2. For this one, everything needs to get multiplied by the square root of 2 and then divided by 2. Okay, but then once you do that, you've got these 2 special right triangles that will help us figure out all our values. So for example, when they tell us that at 30 degrees, remember the first number is going to be your cosine of 30 degrees, your second number will be your sine of 30 degrees. When they tell us that the sine of 30 degrees is 1/2, well, we can see that here. 30 degrees, sine is opposite over hypotenuse, so we have 1/2 over 1. When we're looking for the sine of 60, it ought to be square root of 3 over 2 divided by 1, right? So square root of 3 over 2 for 60, which, yes, that is our sine value right there. If we want our cosine value of 30, it's going to be adjacent over hypotenuse, so it's going to be square root of 3 over 2, which we see there in the cosine position, the first number. Your x value is always going to be your cosine of the angle. And for the cosine of 60, it would be 1/2 over 1, right? Because 1/2 would be adjacent to the 60. And as we expect, we get for 60 degrees for our cosine value, we get 1/2. So one thing we'd notice there is that the 60 degrees and the 30 degrees, they're just flipped over from each other. You get all the same values over here, you just get negative signs that show up based off the fact that once we make it to that side of the unit circle, our x value will be pointing in the negative direction, or once we get down below, our y value is pointing in the negative direction. But the absolute value of those fractions should all kind of remain constant. So although this is a very, very busy looking object here to understand, it really just comes from a few simple triangles and from some understanding about how this thing is set up, that we have a radius of 1, that we've got degrees, that we've got radians, which we can get to from degrees. Okay, so let's take a look at example number 1 here. Find sine and cosine given a point on the unit circle. The terminal side of this angle, theta, in standard position intersects the unit circle at -12 thirteenths and 5 thirteenths. Find cosine of theta and sine of theta. Well, as they're pointing out right here, cosine of theta is just that first point, right? It's just the x coordinate. The sine of your angle is the y coordinate. So that's all we would plug in. Cosine of theta is -12 over 13. Sine of theta is 5 over 13. Right? And that is all there would be to example number 1.